Let's discuss Leetcode problem number 23, merge sorted linked list. Before we discuss, please share, like, subscribe and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. You are given like k linked lists and all of them are sorted. So you need to basically like this 1 4 5 1 3 4 and 2 6. Now you need to merge them into a single linked list like this. You need to get to the linked list like this. So that's the problem. So I think priority queue will work the best, but I have the pattern as like add head nodes to PQ pattern. So we want to add the head nodes of the linked list to the priority queue. So and then basically because it's a min heap, you keep extracting one from each of the lists. Whenever you extract a node from a linked list, you add the next one to the priority queue. And so by doing this process until the priority queue is empty, you accomplish the task. So this is a comparison function because it's a list nodes itself you're adding to the priority queue. So you need to define a comparator function. A dot val should be greater than b dot val. And so now in the case of you define the priority queue min heap as the what you are going to store. You are going to store a list node star pointer to list node, and the container which the priority queue uses will be priority queue vector, and this is the comparator function which basically is the min heap. Now this is where you initialize. You just pick all the head nodes and add them to the min heap, basically priority queue. I'll be using the min heap and priority queue interchangeably in this video. Now you start the dummy head node, and that makes the task simpler. So you'll delete it at the end. So you create a dummy list node. Now, as long as the priority queue is not empty, you pick the topmost element, which is the smallest one because it's a min heap, and then you basically dummy node tail is the pointing to the dummy node. So dummy node dot next becomes the you set that to the smallest. Now you move the tail to the smallest, basically. So in this case you add the node 1. If you see in that example, we'll run through it. You add the node number 1 here. Tail is pointed node number 1 in this step. Now tail is pointing to whatever this one node is pointing, which is 4 here. I think in this case it is 4. So because it's from the first list, and so if for the smallest dot next is not null pointer, you push that node. Whenever you extract a node from a linked list, you push the next one into the heap, and you keep doing this until the heap is not empty. At the end, basically you return the merged head is dummy node dot next. You delete the dummy and then return the merged node head, and that's it. And let's do the run. You basically pick the 3 head nodes like 1 1 1 2. You added them into the priority queue. Now you are trying to process the priority queue. The size is 3. You pop the value 1 from the priority queue, and then now we push 4 into the priority queue, and that's what is happening here. I showed you. So this is where 4 is being pushed onto the priority queue. Then priority queue size becomes 3 again. Popped 1. Now you pop this one from the queue, and so now you push 3 onto the priority queue. This one. Next you extract 2 and then push 6 onto the priority queue. Now you extract 3 and then push 4, and then you extract this 4 and then add 5 to the priority queue, and then you because then you extract this 4 and it is null, pointing to null, so you don't do anything, and then you extract this 5 and this is null, so you don't do anything, and then you extract the 6, and so that's where the merge list is formed to null pointer. And that's it. Let me know if you have any questions or comments. Comment below, and otherwise I will see you in the next video.